Wake up, work out, look great, and kick ass. Boom, what's up? What's happening, guys? Today we'll be doing sigma notation. What is sigma notation? Basically, what sigma notation is that symbol there. That little symbol that looks like an E, right? A weird looking E. What does that symbol mean? It means addition or sum of. So it means addition or sum of. Okay, so if we look over here, this is in more of a, in context, how it would look in your paper, right? Or in an example. So this is N. What is N? N is the last term in your series. Sigma notation is used for series, not sequences, because this is the sum of or addition. Is as if you remember in the formula that we spoke about a video back about arithmetic and geometric series. Sum. There's a sum of, not a sequence. This is a sum of. So k at the bottom, k is equal to 1 is the number that you first substitute into your equation, right? So if I'm starting my sequence, right? So my sequence would start with k is equal to 1. So my first one, I would say k squared, right? What is k? K is 1. That's where I start. I don't start with 0 because k is equal to 1 at the bottom. That could have been k is equal to 0. So in my sequence, I would write k squared. What is k? What is the k? It's 1. So it'll be 1 squared. The next one will be 2 squared. And then it will be 3 squared. And then it will be 4 squared. And so forth and so forth. And then we get to the last term. Because that last term means that we must stop. So if that number n is 10, I must do 1, 2, 3 all the way until 10. I can't go further than that. Right? Because that's the range that I'm supposed to stay within. Right? So the total number of terms, right? So if you can tell now, if k can be changed, if I can start k is equal to, let's say I started k is equal to 5. The total number of terms is not 10, right? The total number of terms is only 5 if we're going up to 10, if n is equal to 10. So since n is equal to 10, the total number of terms would be the top number, which is the n, minus the bottom number plus 1. Sorry, that is plus 1, right? Why do we add 1? Because we're taking into account that we including that number that we're starting with. So it would be, let's say for example, it would be 10 minus 5. 10 minus 5 gives you 5 plus 1. Because there are actually 6 terms in total. Because you're counting 5, 6, 7, 8, 9, and then 10, which is 6, right? So let's do an example so that we can be on the same page and see what I'm talking about. Okay, so this is my example. My example says calculate the sum of 2k plus k, right? So up to 10, that's the last term. And we're starting at k is equal to 1. So what do we always do? What should we do first? What we should do first is expand this. What do I mean by expand? I mean that I need to see a series, right? Because right now I don't know what the series looks like. So I can't determine whether I will sum with the formula for geometric, arithmetic, or any other format. So I have to know what type of series it is before I can determine that. So I need to expand it. So by expanding it, I mean I'll write is equal to, right? Equal to, what's the first term? What did I say? K is the first number that I will substitute into. So it will be starting at 1. So 1 plus 1, right? Because I'm replacing the k's with 1s. It'll be 2 times 2 gives me 4. Plus, okay, if I put now, what's the next number? The next number would be 2, right? So I'll say 2 times 2 plus 2. That is 2 times 4. What's 2 times 4? That's 8. Plus, right? Let me write one more, right? So this is 2 times, what's the number? 3, right? 3 plus 3 gives me 6. 6 times 2 gives me 12. Plus, and so forth, right? I only need to have 3 so that I can check what type of series it is, right? So, you could go all the way to 10 with this, right? You could do this and then put 4 and then put 5 all the way until you get to 10. Of course you can do that for this one here because the number over here is low. But if it was, let's say 30, that would take forever, a lot of wasted time you could have used on another question. So that's why we have to use a formula. A formula will help us to get these things much faster, right? So what formula do? Some of you guys are being stopped from doing great things because you're holding yourself back. Like you don't have, it doesn't matter that a lot of people or nobody in your family has ever gone to university. Why don't you be the first one, right? Put that thinking, that mindset, that backward thinking behind you. And start thinking, let me be the first one to go to university. Let me be the one to take my family to a better level. We already know the formulas that we're going to use. It's just now we need to derive what type of series it is. So how do we do that? Let's find there. Let's go like this. So 8 minus 4. Let's test if it's arithmetic, right? 8 minus 4 gives us 4. Then 12 minus 8 also gives us 4. What does that tell us? That tells us that this series is arithmetic. If this series is arithmetic, what formula do we have to use? We have to use the formula Sn is equal to n divided by 2 brackets 2a plus n minus 1 multiplied by d. This is the formula that we use because we know the difference, right? And we know the number of, do we know the number of terms? No, we don't know the number of terms. Why? We have to calculate it, right? But we can assume what it is, but let's just calculate it. How do we calculate it? Right? One who says total number of terms, so I'll write n. Right? N is the total number of terms, by the way. This n right there, total number of terms, is not that number there. That number there means last term. Last term, no total number of terms. Right? So n is equal to, what did I say? I said top number minus the bottom number plus 1. Right? So what is the top number? The top number is 10. So we have 10 minus 1. Why? 1 is the number at the bottom. If we started at k is equal to 2, we'll say 10 minus 2 plus 1. It will always be plus 1, right? Just to include the first number or the last number, right? So 10 minus 1 plus 1 will give us, obviously will give us 10 because we're starting at 1. So it doesn't make much of a difference, right? So now we have n, the total number of terms. Now we can plug in the things that we know into our formula, right? What do we know? We know that a is equal to 4. And we also know that d is also equal to 4. So let's put everything in our formula. So we'll say s of what? Of 10. Because those are the total number of terms, is equal to 10 divided by 2, 2 times 4 plus 10 minus 1 multiplied by 4, right? So now this is basically it. We have solved this question. This was not too bad. This was quite easy. Now just put in your calculator and see what value you get. The value that I got was 220. So the sum of this function between 1 and 10 is equal to, what is it equal to? 220, right? So that's example 1. Let's look at another example. Let's look at example 2. Okay, so our example 2, what does my example 2 say? My example 2 says that find the sum of 2 in the bracket k minus 1 to the power from k is equal to 1 to n. But the sum of that whole thing is equal to 381, right? Now find what n is. N in this instance means the total number of terms, not the last term, right? But in this case, it doesn't really matter. Why? Because we're starting at 1. Since we're starting at 1, that term, it doesn't matter whether we're saying n is the total number of terms or n is equal to the last term. Because if we say, for example, 10 minus 1 plus 1, it will still be 10, right? So the last term and the total number of terms are equal in this instance, right? So, but be careful next time, right? So what do we do first? What did I say we do first? We expand. What do I mean by expand? What I mean is you must substitute. What's the first value that I must put in? I must put in k is equal to 1. So k is equal to 1. I'll say 3 k to the power of 1 minus 1 gives us 0. So 2 to the power of 0 is 1. So this we have 3. Plus, if I put 2, now it will be 2 minus 1, which is 1. So 2 to the power of 1 is 2. 2 times 3 gives me 6, right? Plus, now we have 3. So it will be 3 minus 1, which will be 2, right? 2 to the power of 2 is 4. 4 times 3 is equal to 12. So that's how I end up with 12 plus, right? And so forth and so forth, right? I don't need to look for all of the terms, right? So now what do I do? Right? Am I stuck? Where do I go? What's the next step? The next step is to check what type of series this is. Okay, how do I check? Cool, let me check. 6 minus 3. What is 6 minus 3? 6 minus 3 gives me 3, right? And then 12 minus 6. 12 minus 6 definitely does not give me 3. It gives me 6, right? So, therefore, I can't use arithmetic. Let me check geometric, right? So, if I say 6 divided by 3, it gives me 3. Gives me 2, sorry. Gives me 2. And then if I say 12 divided by 6, it also gives me 2. What does it mean? It means that this series is geometric. So what formula for addition do I use? The geometric formula. But what did I say? I said that 6 divided by 3 is what? Is 2. Is 2 greater than 0 or is it less than 0? Last time I checked, it is greater than 0. So therefore that means that the formula that I'll use would be this one. So this is the formula that I will be using because r is greater than 0. Why? Let's show you why. R is equal to 6 divided by 3, which is equal to 2, which is also equal to 12 divided by 6, which is equal to 2. Again, I can't just say 6 divided by 3 is equal to 2, therefore that's equal to r. No, I have to check that it's consistent. So the next part, I can say 12 divided by 6 is also equal to 2. So then maybe it is geometric. But if you are still not sure, just add another term over here. So we'll say 4. 4 minus 1. 4 minus 1 is 3. 2 to the power of 3 is 8. 8 times 3 is 24. And then if I say 24 divided by 12, it's also equal to 2. So therefore, r is definitely equal to 2. And this series is definitely geometric. So now we have r. Let's look for a, right? A is equal to what? What is A? We can determine it from our series. It's 3, right? We can deduce it. Mark that word. We can deduce it from our series, right? So now let's work with our formula. Let's put in what we have and let's see what we don't have. So Sn, okay, before I put that, Sn, right? Do I know what Sn is? What am I looking for in this equation? I'm looking for n. The total number of terms. So I know that for a fact I will not have n, right? Because that's what I'm looking for, right? I have a, I have r. Do I have what Sn is? Yes, that's what they told me. They told me that the sum of this is equal to 381. So therefore Sn is equal to 381, right? Which is equal to, what is a? My a is equal to 3. My r is equal to 2. So this will be 2 to the power of n. Because I don't know what n is, that is what I'm looking for. And at the bottom we have 2 minus 1. Right? That's my equation. Well, how many unknowns do I have in my equation? Only 1. Right? Since I only have 1 unknown in my equation, let me multiply. Let me get rid of the denominator. But what is my denominator? 2 minus 1. 2 minus 1 gives me 1. So therefore, if I multiply both sides by 1, it doesn't change anything, right? So the 1 just disappears, right? Because anyways, that divided by 1 is still what's in the numerator, right? So now what do I have? I have 381 is equal to 2 to the power of n minus 1. So now what do? I can divide both sides by 3 so that I can get that bracket to open up. So if I divide both sides by 3, I'll get 128, which is equal to 2n minus 1. 2n minus 1, right? So again, I want to get the n by itself, so I take the 1 onto the other side. It becomes 129, right? So now I have 129 is equal to 2 to the power of n. 129 is equal to 2 to the power of n. Now, this is a little bit tricky part, right? How do I get n to be at the bottom? I can use logs, right? I can use logs. How do I use my logs, right? I say log n is equal to, because I know that if I use my log, I can remove that exponent and bring it down to the bottom. So I know that n will be equal to. N will be equal to what? So I'll say log the base of whatever my exponent was. So my exponent was n. What is the base of n? The base of n would be 2. So that would be.
Sleep early before you write an exam. I know a lot of you don't do this. Sleep early before you write an exam, and don't sleep early and say you wake up early. Don't sleep early and say you wake up early to go and study. You won't wake up early. What happens when you don't wake up early? Now you have an exam and you're not ready for it. You might be ready for it, but in your mind you don't think you're ready for it because you didn't wake up. So sleep early when you're writing exams. How can you do this? Because you have studied for the exam in advance. So you don't need to be cramming things the night before.
The base of my log, right? And the number on the inside of the bracket is the number that was on the other side, right? So now I have log 2 of 129. And log 2 of 129. Sorry. This is 127. And then when we add 1, it becomes 128. And then that's how I have over here 128. Sorry, my bad. I made a mistake over there. I added 1 in this before. Okay, so that's how I now have log 2 of 128, which is now equal to, what is this equal to? This is equal to, just put in your calculator and see what value you get. I got 7. What does 7 mean? It means 7 is the total number of terms that you have, and also it is the last term. Why is it the last term here and the equal to the total number of terms? Because k starts at 1, but if k started at 2, it would not be the total number of terms, because it could be 7 minus 2 plus 1. Then I will have only 5 terms, right? Because if I say 7 minus 2 is 5 plus 1. So I would have a total of 6 terms in that case, right? So, but in this case, we're starting at 1. So I have 7 minus 1 plus 1 gives me 7. And that is basically it on that. So now let's look at sum to infinity. Okay, let's look at sum to infinity. Okay, so first thing we should look at first is the equation for sum to infinity. What is the equation for sum to infinity? This is an equation for sum to infinity, and you should commit it to memory, because if you know this equation, when you get a question about sum to infinity, it will be straightforward and easy. Sum to infinity is equal to a over 1 minus r, right? A over 1 minus r, right? But we can only use sum to infinity only for one specific rule. If r is between -1 and +1, right? What is r again? The ratio of your series. So if r is between -1 and 1, we can use this formula of sum to infinity. But if r falls out of that region, we can't use this formula. Why? Because that series is divergent, right? But if the value of r is between that means that the value is convergent. It stops at some point, right? So this is convergent. And anything else is what? Is divergent. So if I get a value of, let's say 3, that would be divergent because it doesn't fit under those rules there. So let's look at it. Let's look at an example. Example 1. Okay, so example 1. This is my example 1. We want to look for the sum to infinity of this. Okay, so what's the first thing we need to check? We need to check that the series is convergent. Because if it's not convergent, we can't use the sum to infinity formula. And we can't conclude, we can't find the sum to infinity, basically. So what do we do? Right, let's check what it is, right? So by checking, we're saying R is equal to, what is R equal to? R is equal to 8 divided by 100 divided by 8 over 10. So what I'm saying is 8 over 100 divided by 8 over 10 is equal to, what is that equal to? You can put that in your calculator and see what value you get. I got 1 over 10. Right, that's what R was. But again, I can't conclude that by just doing the first one. I also have to do the second part. So try this part there and see if you also get 1 over 10. You should get 1 over 10 too. Right? So this is my R. Right? 1 over 10. What is 1 over 10? 1 over 10 is a small little number that is definitely between -1 and 1. So what does that mean? It means that this series is convergent. So therefore I can use that formula, right? So a quick note before we get to that, they might ask you this question in a different format. It might look like something like this. Because if you have 0.8 and then we have a dot on top of it, what does that mean? It means that that number is 0.88888888 all the way to infinity. It continues to go like that, right? That number cannot fill your calculator. That's why you have 0.8 and then it stops there, right? But that number continues to go on. So another way you can have something that looks like the 0.91. Right? If you have a number like 0.91, we have 2 dots above it. It means that that's 0.9191919191 carrying on all the way to whatever infinity is, right? So that's just a quick note that you should take notes of. Don't forget that. Let me just, is equal to 0. Right? So now let's get back to what we're doing. So what do? We said that we know what R is. Right? Do we know what A is? Yes, we can just deduce that from the equation. So it will be 8 over 10. Right, so now let's write down our formula because I think we have all the values that we need. So sum to infinity is equal to, what is it equal to? What is A? A is 8 over 10. Right, we have 8 over 10. What's at the bottom? 1 minus R. So 1 minus, what is R? 1 over 10, right? So then now, that's basically it. That is sum to infinity. Straightforward, easy, 3 marks. So just put this in your calculator and the value that you should get is 8 over 10. Okay, that's easy, right? Those are 3 marks. Why would you deny 3 marks? Go get your 3 marks, right? Go try this on your own. Don't just look at me and then once I've done it, you say you understand it. No, you don't. You don't understand it. Go do it on your own without looking at my answer, right? Okay, so that's it. Boom. Go check out the next video.